Today we are looking at special right triangles again. This is day 2. Your essential question is, how do I find missing measures in special right triangles? Your learning intention. I'm learning to find missing measures of special right triangles. You've got 3 warm-up questions. Pause the video and see if you can do the warm-up questions now. Well, I hope you've tried on your own. If you're looking at the first 2, these are found by using the Pythagorean theorem. We know that a squared plus b squared is equal to c squared in a right triangle. We've got the 2 legs, so we are looking at c. So x squared will be equal to 5 squared plus 12 squared. What is the opposite of squaring? Taking the square root of. So x is equal to the square root of 5 squared plus 12 squared, which is equal to 13. This is what we would call a Pythagorean triple, because all 3 of the lengths of the sides are whole numbers. What about the next one? Can you do the next one on your own if you didn't try on the first one? Well, this time we're looking for a leg. When we look for the hypotenuse, we add. When we look for a leg, we subtract. So x squared is equal to 15 squared minus 12 squared. Opposite of squaring is taking the square root of. X is equal to the square root of 15 squared minus 12 squared. This time it is 9. Once again, this is a Pythagorean triple because all 3 of the side lengths are whole numbers. Okay, now the next one we're going to find all the missing measures. This time we have to use sine, cosine, and tangent, or tangent. So if I'm looking at this, the easiest one to find is that missing measure of the angle. So if this is 50, this has got to be 40 degrees. Why? Because this is 90, that means these 2 together are 90, and that missing measure of the angle is 40 degrees. Now you have to decide. To find x, do you want to use 40 or do you want to use 40 degrees or 50 degrees? You know you've got the hypotenuse. Remember that. So, toa. If I use 50, this would be opposite over hypotenuse. Opposite over hypotenuse. That would be sine. So the sine of 50 degrees is equal to x divided by 12. I've divided by 12. How do I undo dividing by 12? Multiplying by 12. So 12 times. Okay, once again, I'm going to check and make sure I'm in the correct mode. I am in degree mode, so I'm doing good there. So 12 times the sine of 50, and I get 9.192. So this is approximately 9.19. So if I use the 40 degrees, I could use sine again. If I use the 50 degrees, I have to use cosine to find y. So the cosine of 50 degrees is equal to y over 12. Once again, I'll multiply both sides by 12 because I've divided by 12. 12 times the cosine of 50, and I end up with 7.713, so that's approximately 7.71. Okay, how do I do a quick check? Well, if I want to do a quick check, I will use the Pythagorean theorem. 12 squared is equal to 144. So 9.19 squared plus 7.71 squared, and I end up with 143.9. So if I would have gone out to the nearest thousands, or 10,000s, I would have been a little bit closer, but this is pretty good for an approximation. Okay, are these right triangles? If they are, state which one it would be. So if I'm looking at the first one, I know that if this side is x, then this side is x, and this side is x square root of 2, if it's my 45, 45, 90. So what I'm going to do is take the 4 square root of 2 and multiply it by the square root of 2. If I get 9, then I know it's my 45, 45, 90. Square root of 2 times the square root of 2, it undoes each other, so this becomes 4 times 2, which is 8. So this is my 45 degrees, 45 degrees, and 90 degrees. And this would be 4 square root of 2 also. Okay, for the last one on this page, if I'm looking at this, if this is my 30, 60, 90 degrees, I know that this would be x. This would be x square root of 3, and this would be 2x. So 5 times 2 is 10. 5 times the square root of 5 is 5 square root of 3. And this is my 30, 60, 90. And we're done. So as we're looking at the next page, it shows us what we need to remember. 45, 45, 90, remember you multiply by the square root of 2 to get your hypotenuse. 30, 60, 90, this is 2x. This is x times the square root of 3. So if I'm looking at the next one, I have to think, what are those lengths of the sides? Well, this would be 60. This is my short side, it would be x. This one would be x square root of 3, and this one would be 2x. So let's find x first. If x square root of 3 is equal to 11 square root of 3, what does x have to be? Think logically. What is in the same spot as x? 11. So x has got to be equal to 11. This is 2x, so a will be equal to 2x. which is equal to 2 times 11, which is 22. And we found them all. What about the next one? If I'm looking at my special case, x square root of 2. So if 8 square root of 2 is equal to x square root of 2, then x has got to be equal to what? 8. Okay, take a minute and look and see if there's any questions. If there are, please back the video up and work on it again. Listen to it again. Okay, so looking at the next one. This is a 45, 45, 90 degree triangle. So if I'm looking back up here, my hypotenuse is x square root of 2. 6 is equal to x square root of 2. I have got to solve for x. First thing I'm going to do is to divide both sides by the square root of 2. Six divided by the square root of 2 is equal to x. But I cannot leave it with a radical in my denominator. So I'm going to multiply by that funny looking 1. Square root of 2 over the square root of 2, which gives me 6 square root of 2 over 2, because this eliminates your square root. Is 6 divisible by 2? Yes. This becomes 3 square root of 2. And we're done. Take a minute and look at the relationship between the 6 and the 3 square root of 2. Think hard about, if you know this, how you can find the length of a side. I hope you realize you take the 6, divide it by 2, that gives you the 3, and then multiply by the square root of 2. Quick and easy way to find those missing lengths of the sides. So if I'm looking at the last one, once again, you try to think, what is going on? Well, if this is my short side, so this would be equal to x. My long side is x square root of 3, and my hypotenuse is 2 times x. So how do I use that? Well, I know that 10 is equal to 2x. So x is equal to 5. So a is equal to 5. You always go back to your short side when solving the 30, 60, 90 degree triangles. So b will be equal to 5 times the square root of 3, x square root of 3, and we're done. So how do you know when you're successful? You know you're successful when you can find missing measures of right triangles using any method. So these are special right triangles.